continue on our journey with factoring. So we are solving by factoring now. So we're going to talk about something called the zero product property. The zero product property says that if you multiply two products together, they're equal to 0, and that each of those products can also be equal to 0. So A times B equals 0, then A equals 0, B equals 0, or both A and B equals 0. So again, the zero product property says that if you have two factors being multiplied together, then A could be 0, B could be 0, or both A and B can be 0. So our objective for today is to take factoring one step further than where we were last week, which is to factor and now solve each of those factors. So, for example, last week we were ending here. So this equation is what we call factored form. We set it equal to 0. And then what we do is set each of those factors equal to 0 separately and solve for the variable. So that's what we're adding, or is new today, is going from what's in the blue box that we did last week to now being able to take each of those factors, setting them equal to 0 and solving for our variable. So again, hopefully this is something that you remember doing. It's just that now as we look at our factors, they're going to be a little bit more complicated than some of the factors we had previously looked at in Algebra 1 or geometry. So the directions are the same. These are the steps we followed last week to do the magic X. So that's what we did in yellow. Now we're adding steps 3 and 4, which is to set each factor equal to 0 and solve each factor. So sometimes it's nice just to have those steps. So those are the steps for the magic X. Okay, so in example number 1, the first thing we are going to do is to set that equal to 0. So currently it is set equal to 10. The first thing you need to do are rearrange those terms so they're set equal to 0. That is step 1. So you're going to move the 10 over. Step 2 is to complete our magic X. So you get 3 times negative 10, which is negative 30. And then you have to get 2 factors of negative 30 that sum to negative 1. So again, that's your magic X. And then we see in this case that those two numbers are negative 6 and negative 5. So what you're going to do is, after you have those two numbers, you are going to take those two numbers and replace them. So that's what I did over here in that light blue. So those two factor numbers replace the 6 and 5 in our problem. Then you find the GCF of each factor. And then you get your two groupings of 3x plus 5, x minus 2. Now the only difference is that equals to 0 tags along at every line. So make sure you're writing that all of these are equal to 0. And then the last two steps are splitting the factors set equal to 0 and solving for x. So our last two steps are splitting those and solving for x. Okay. So in number 2, we have x squared minus 27 equals 6x. So once again, I need to get that set equal to 0. So I'm going to subtract 6x. Then I'm going to factor. So what's nice about this one is that the a value is 1. So it's two numbers that multiply to negative 27 and add to negative 6. So that's negative 9 and positive 3. And since my a value is 1, then those two numbers just go directly in. So you have x minus 9, x plus 3. And then we set our factors equal to 0 based on the zero product property. And then I solve for x. So I'm going to add 9 and subtract 3. So you get x equals 9, x equals negative 3. Okay, example number 3. Once again, we have to rearrange our terms so that it is set equal to 0. So we need to add 5x to the other side. And then we have our magic x. So you multiply 2 times negative 3 to get negative 6. So I need two numbers that multiply to negative 6, but add to 5. So that's a positive 6 and a negative 1. And anytime I put in a negative, I like to write my negative first. So I'm going to do 2x squared minus x plus 6x minus 3. Equals 0, because again, we got to make sure we have our equals 0 now. We're going to do factor by grouping. Taking out our GCS. I take out an x, leaving 2x minus 1. I take out a 3, leaving 2x minus 1, equal to 0. So we have x plus 3, 2x minus 1, equals 0, and then x plus 3 equals 0, or 2x minus 1 equals 0. Therefore, x is equal to negative 3 is one root, and x equals a positive 1/2 is my other root. So again, quadratics will have two roots unless the vertex is on the x-axis or the problem is non-factorable and shifted up or shifted down and reflected. So when we were graphing, we saw that there were three cases for quadratics. 2 solutions, 1 solution, or no solution. The same holds true with factoring. So this is one that tends to trip students up. This is a case in which we're looking to pull out a GCF. So there's not a C term. That means the y-intercept is 0. So that means 0 is going to be one of my roots. So I'm going to take out a 2x, leaving me with x plus 4. So 2x times x gives you that 2x squared. 2x times 4 gives you that 8x. This is considered factored form. So 2x equals 0 is one possibility, and x plus 4 equals 0 is another. Therefore, my answers are x equals 0 and x equals -4. So again, those are the roots. Okay, so you're going to do the front and back of the next page in that worksheet. So you're doing 1 to 20. You can use the remaining 6-7 minutes of class time to start on that. I do need to see all the steps, so you need to make sure you set them equal to 0 on every line. And it is helpful just for checking purposes if you box in your answers so that when we go over them, you can more easily check and then work backwards from those. 1 through 4 on your homework are considered factored form. They're like that first example we did. So you just have to set the factors equal to 0. From 5 on, you have to do the factoring for them.